Hello and welcome to another Solana tutorial. Today we're gonna talk about Mollusk. Mollusk. Basically a testing suite for Solana by Anza. Cause testing is important. Kids, do your testing. And for you to be able to do your testing efficiently, you wanna have nice tools that help you with it. Cause basically when you write a Solana program, in order to test it, you either need to spin up a local validator or you use the cluster, but that's even a step further. That is not suitable for real testing. A lot of test cases and stuff. That's done for user testing and integration testing, okay, but like for unit testing and stuff, nah. But if you want to run your Solana program locally, just execute the process instruction, you can do that with a more lightweight setup. And that's what Mollusk promises. I haven't actually tried it. You know me. I don't try the things before I make a video about them. That's just how we roll here, to get the real first use experience. And we did have a look at, what was it called? Surfpool, which does a similar thing and more. But I think Surfpool does actually have an entire VM. Although don't quote me on that, I have no idea. I just want to try out all the tools that are available for Solana devs and then see which ones are the ones that I like and that I would recommend. So stay until the end of the video to figure out whether or not I would recommend Mollusk. And for me to figure that out, what I'm gonna tell you here, let's have a look at Mollusk. So we're talking about an official Anza project here, Mollusk. It's a lightweight test harness for Solana programs. It provides a simple interface for testing Solana executions in a minified Solana virtual machine environment. So the SVM, Solana virtual machine, that's what the Solana programs run in. So to run our programs, we need to have that. And a validator will spin that up for us, but running an entire validator is, expensive. And not just in economic terms, even if you simulate it locally, a validator has a lot of parts that you need to run. So we don't have any accounts DB, we don't have any bank or other components. All that does is it creates a semblance of a validator runtime. But this thing does not spin up the validator runtime, but instead provisions a program execution pipeline directly from the lower level SVM components. So basically, we just use the components that are relevant for program execution and don't do any of the other stuff. So the main processor, so that's what's called when an instruction of a program is called, the process instruction, creates minified instances of Agave's program cache, transaction context, and invoke context. So those are the three things that we need. And then we use those components to directly execute from the ELF using the BPF loader. All of that comes at a cost though. It requires us to explicitly provide the accounts. So we need to set that up manually. And I would say we just try this out. Let's just try and test single instructions. And for that, we'll need a program. A program to test. I'm not creative. I'm gonna just do my program and cargo init here and make it a Solana program. I shouldn't import the whole Solana program crate. Although to make it easy for us, let's add Solana program because I can't be bothered to figure out where the individual crates are. And then let's write an actual program, no tests. So all we do here is we have a simple entry point and we process instruction and we say program called. I mean, my program should do something. All we do is check an account, first account, next account into, mute, there you go. What do you need? I need a mutable reference. That's what you need. There we go. Okay. I'm out of practice doing Solana programming. This also seems out of date. By the way, I got that example from here, from the Solana docs. Just copied this. So you're complaining entry point is not a macro. I mean, should we do it cleanly? But it's a crate, not a macro. Here is the macro. There you go. Unexpected condition value. I'm missing something else now, don't I? So, I mean, we're talking about Mollusk here, but really, we're doing Solana development, as a good Solana dev does, every few months, because things change. Also, we're forgetful. But anyway, let's first finish this part of the program, and then we fix all of those things. So I'm getting the first account, so I'm expecting there to be at least one account that is parsed into my program, and then I just do a signer check. I just check if that account is a signer, and if it's not, then I'd be like, error. Missing required signature. Although is that the right thing? I need to do another deep dive on all those errors. Remind me that I do another deep dive on all those errors because I'm not sure when which one is actually used. But what I want to say is this account is not a signer, so it's an account thing. Incorrect authority. Inverted seeds, inverted argument. I'm gonna use this for now, but even though I'm not sure that that's the right error. Or maybe I shouldn't use any of them and only use custom, but no, that's also not the right strategy. I know other programs use those. I mean, I could do a custom, but that doesn't tell me anything. Anyway, we'll just do that. We're missing a required signature. Yeah, because the account is not a signer, therefore there is no signature, therefore I think that error fits here. Anyway, that's my entire program now. That's all we do. We just do a signer check on this first account, and otherwise we say okay. And of course, you will use your own programs, but for a simple example, this is what we do. Cargo build SBF. Okay. What? Didn't I just add that? But that feature is not stable in this version. So that's the same for this thing now, or what? Failed to download base 64 CT. I mean, that's what you get for using Solana program with all its dependencies. Because then I need to, download and build all of the dependencies. Let's see if there is a quick fix. Either I Rust update, or use an older version, or I pin it. Or I try to get rid of it by not including Solana program, but instead all of the things that we need here. Oh, actually, hold on, give it back. And then we can see where it comes from actually. So this is from Solana account info. So I'm gonna cargo add Solana account info. This is from Solana program entry point. And this is from Solana message. And this is from Solana pub key. Cargo add Solana pub key. There you go. And with those dependencies, we can throw out Solana program. Hopefully, we're in version 3. Wow. I missed that jump somewhere. Should I do a deep dive on what changes in version 3? I kind of want to, because I have no idea what changes in version 3. And it seems to be a major version change. I'll put that on my list as well. So, let's not use this. Let's use this. Was that directly here then? Yeah, there you go. Solana pub key, and Solana message, and program entry point. Oh, and the program result. Do we have everything now? No. Program error. We need program error, and that's in, where was that? Program error. Solana program error. But without Solana program, it's where? What does the program result return? Program error. Where does that come from? Do you have a program error? No? Can I see the definition of that? Program error. Where does it come from? Enum program error in Solana program error. Solana program error. I guess I got a cargo add Solana program error. And then I can import that from there. Modularity for the win. Okay, anyway. With those changes in dependencies, hopefully, if I build it now, I don't need the dependency of this, what was it, base 64 something, because I will need fewer dependencies. And with fewer dependencies, it will compile. I love it. Okay, amazing. Isn't that great? Okay, so, but we still have this warning that I don't quite understand. Adding custom panic as feature in cargo toml. It seems like custom heap. That very much reminds me of what we know from Pinocchio, where we need to add the heap strategy and the error handler, like the panic handler. And I guess none of them it has. Maybe that's something that changed with 3.0, but it's just a warning. So let's just ignore the warning for now and see if we can, run the program. We get our deploy program binary, and this we could now deploy somewhere. There you go, I still have a key. I still have Sol, might as well. Deploy, just real quick, just to see. There we go. We are deploying a program in 11 transactions. Wow, nice. So that's also quite nice and small. Not as small as if I did it with Pinocchio, but 11 transactions is not a lot. And I deployed to DevNet. So let's check DevNet. DevNet, hello. See, I mean, that's a reason why you should not test by using DevNet, because that will just take you forever to get anything done. Wonderful. Okay, Explorer is not helpful. Yeah, there you go. Here we see, we deploy the program. That's the data. Program is deployed. We could now, of course, test it by calling that program. Should we do that? And just to practice how that is done in Rust, I think I want to do that. I usually do it in TypeScript with a kit, but I want to do it quickly with Rust. Let's do that. So let's do a testing application where we cargo add the Solana SDK. For now, we might still scrape the rest that we don't need. Do they also have a sample for testing stuff here? Invoking a program. Oh, you have it in the same. Yeah, that's fine. If you want to know how it's done, I basically just copy stuff from the internet. So, wait, what was my program ID? That's my program ID. We connect to DevNet, which totally, this is not DevNet. The docs seem like they're vibe coded. No, that just happened. That's a copy paste error. Whatever. We know better though. Here you go. Oh, they do create a new key pair. I don't want to do that. This is not sufficiently. Oh, the Rust analyzer never likes having two. How about I open it here then? Do I get the analyzer then? Yeah, much better. There we go. So from seed, write to file. Is there a read? Read from file. I want a dev wallet. Dev K. Drop them some sol. Then put that here. Voila. Wait, what? Oh, I need to import some stuff. Then it works. Is a result for a key pair or a boxed error? How about expect couldn't read keep file? Okay, we need Solana client as well. Okay, and then that looks good for now. I kind of like Rust. There's something to how Rust looks that makes me be like, yeah, I kind of like Rust. I don't know why. But anyway, the airdrop, I don't care about that because we have a key pair with like actual sol there now. So we don't do that stuff. Then we create the instruction. So this is the interesting part now. An instruction to our program ID with, yeah, okay, let's do with no accounts at first and then we see it fail. And then we build the transaction with the payer, sign that with the latest block hash, and send and confirm that. Wonderful. Easy. Let's do that. Do you think I can cargo build this without it expecting the 2024 edition thingy? Because here I have the entire SDK and the entire Solana client now as dependencies. And there is something red. I don't like it. Unresolved import. I mean, it went quite far, so it was able to build all the dependencies pretty much. But then my program, it won't be able to build because of those things. Unresolved. Do we even need this? Where do I need this commitment config? I don't think I need this. And then here, so either I add Tokyo or I remove that and just run it as a normal main function. I don't need this with threading. Oh, I do need the commitment config. Hold on. But maybe then I can't await. Okay, damn it. Config, program, no. Damn it, where do we get the commitment? It's probably in the client though, no? Connection cap. It's weird that it doesn't know that at all. RPC client, new with commitment config. Via commitment config. I can't find it. Cargo, add, Solana, commitment config. That's a thing. Did you know? I just had to look at the docs here. Solana, commitment config. And then I can import it. There you go. Fixed it. Okay, now that should build. Voila. And now we should be able to say cargo run. But then it panics. Couldn't read keep file. No such file or directory. So I have the wrong path because I'm running it from where? From dot. Okay, maybe then I just need dot keys. Build again. Yeah, that looks better. Okay. So see, we can use the RPC to test this. The program that is deployed to DevNet. It's being invoked. It does our log. Remember, that's our program. That's what it does. It says program called and then tries to get the account where it then obviously fails. Insufficient account keys for instruction. This here errors. The next account info will give me a program error and the program error being not enough account keys because we provided 0 accounts. Where did we do that? Here. 0 accounts. No accounts needed. Well, shut up. We do need accounts. I will now need to add an account meta here. Account meta with the pub key. Let's use our payer pub key. Is signer false? Is writable false? Let's see if we can do that then. Oh wait, before we run this, we gotta cargo build and then cargo run this. There we go, we got a transaction signature. Oh, I know why. Because I'm an actual signer. Even though I say is signer false here, but because I'm the fee payer, I am a signer, so that's why it works. Because on transaction level, we are a signer. So even though we didn't in that instruction request it to be a signer, it is a signer. and it is a signer to the program as well, because nobody else removed the privileges, because there's nothing else. There is no other instruction. There's just the instruction to our program. And here that account is a signer. Therefore, we return success. Okay, so that's one way of testing it. If it was a different account, just to prove that as well, like if we had a let new account be a key pair new, and I would put the new account pub key here, then obviously that shouldn't work, and it should give me my error of missing signatures. There, missing required signature for instruction. Only if I say is signer true will that work. However, before that will work, it will fail here in the transaction signing. I'll show you that as well. So now I won't even get to the part with the RPC, because I will already fail. I will already panic in my main, because transaction sign failed with not enough signers, because my transaction sign now also needs this new account to sign with. But then I can sign with both of that. Ooh, that's a nice transaction signature. 333, love it. And here we have both accounts being signers, and that account 1 here in this instruction is a signer to it, and therefore all is good. The program does not complain. So that's the manual way of testing this, which is obviously super inefficient and demanding, because I need to do a lot of the working with the RPCs, building the transactions and everything. And it's also super slow, because we are literally depending on the RPC and DevNet to operate. We could do this locally, right? We can spin up a local validator, do it locally. Then we could even do it offline. That would make it better and faster. But we can still do better by not having to worry about validator stuff at all and just using Mollusk. So let's try that. Basically, we just add Mollusk SVM, and then we can have this dependency, and that's all we need. So let's do that. Let's do Mollusk testing. I'm gonna again use a new here. So let's again do cargo init. I'm just gonna copy this and put it here in my source file, and then I'll just need to add the things that I need, which is cargo add the Solana SDK and Mollusk SVM, I guess. Well, whoa. That's a lot of dependencies. Holy, is that from the Solana SDK or from Mollusk? From Mollusk, or from both of them? I don't know. In version 0.5.1. Oh, it allows for fuzzing. It has those features. Well, let's not get ahead of ourselves. We might look at that in a future video. For now, I just want to run it like a simple script. So I define my program ID, then I define 2 random keys, okay? Well, it's not random, it's just the unique ones. Here we're missing some imports. Okay, program ID is an address. Oh, another idea for another video is talking about that, because that is confusing, but they're moving in the right direction. Solana address, it's a Solana address, a pub key. Pub key is a Solana address. This is confusing, but it is indeed, the right word is address. That's why they're changing it. Maybe that's why they updated to 3.0, because it's now all address and not pub key anymore. But of course, that might lead to problems here, because it expects a pub key and we have an address. Great. Yeah, I mean, that's a whole different story for a future video. So how do I fix that now? I mean, the easy way is to use an old version of Solana SDK as well. But is there a better fix? Must be a better fix. I hold it on pub key and it says address. I mean, do I have a better idea than downgrading my SDK? We have, yeah, since half a month we have version 3. Before that we had 2.3.1. Let's just see 2.3.1 if there we still had pub key. Yeah, we did, probably. Let's see. Wait, hold on. And will it be pub key? Will it be pub key? Yeah, no. Still an address. Still an address. No, pub key. Woohoo! I mean, this is not how you should do it, probably. But how you should do it, I will talk about in a future video. I want to get to Mollusk, and I can't get distracted with all of those things. So for now, we just downgrade the SDK and pretend it's August and not September. So yeah, just downgrade. It's fine. It's a pub key now. That's exactly what you need here. Pub key, perfect. But let's see what's actually written here. I keep copying code and not really writing it myself. we build an instruction as you would. I mean, that's the same thing we did here as well, right? We build an instruction. We did it here with Borscht. Same, almost. But the type is the same. It's a Solana instruction. And here we have two account methods. Or this is how you should do it. Account meta new. I just did it the hard-coded way. Okay, so new read-only and new, you know what? I'm gonna just do a new read-only with key 1, which is not a signer, not writable, just to test. And then we need to provide all of the accounts to that transaction because, again, Mollusk will just capsule that context and then call the process instruction directly. So we just need the one account. It's gonna be interesting because in this setup, we also just don't have a fee payer. This is just not part of it. But we just test the process instruction and not that entire transaction level stuff. So that's fine. So we create a new Mollusk with that program name, my program. Oh, how convenient. That's literally how I called my program. And then we execute the instruction and get the result. And then we just print the result. There we go. I just print it for now, just to see if I can run this. Can I cargo build? Most of these dependencies are probably the whole Solana SDK because, again, I imported the entire Solana SDK. I don't need all of that. I could be more modular like I did with the program. But I was being lazy, so I just did that. That's fine. So Mollusk VM is the dependency I have, and Mollusk testing is my own program. Built that. Let's run it as well. Oh, we panic. File not found. That's right. You are searching for the program file, the my program, which is not here because it's not in this very project. It's in a different project. So you want this to live in the same project then, don't you? But what if I don't want it to live in the same project? Or what's the good practice way to do this? Well, okay, let's put it in here. Fine, works for me. Let's do in here tests and then Mollusk RS, or let's call it Mollusk tests RS. Test, simple instruction like this. And then I'll just do all the thing that I have here in my test. Here, how does that look? Bad, because I need all the dependencies. Okay, Solana pubkey, which is an address. Oh, I'll have the same problem here as well. Instruction lives where? Solana instruction. Well, I guess cargo adds Solana instruction. So we can import this and this and this. And then we'll need the Mollusk SDK. Cargo add Mollusk SDK. Let's see how many dependencies that actually has. Oh, couldn't be found it. What was it called? Mollusk. Oh, SVM, sorry. SVM. It's the Solana virtual machine. Yeah, it does have a few dependencies. That's still... Wow, okay. And plus, look at that. All of those Solana dependencies, they are now also in here. Now I have all of them added anyway, because the Mollusk SVM needs it. Okay, how are we doing? Are you gonna complain again that this is not an address? Now I can import that though. And of course then it's gonna complain. Oh wait, no. Expected reference Solana pubkey, found reference pubkey. Still just different. Two different versions of crate Solana instruction are being used. Two types are coming from different versions of the same crate, but the different types, even if they look the same. That sounds like dependency issues. So I said I want all of these things, but Mollusk says it wants what? Ah, yeah, look. Mollusk is still on the 2.3, and pubkey 2.4. That's why. Well, again, I don't see a better solution than downgrading my own shit to have it be compatible, because otherwise I'm just gonna run into issues. Until Mollusk updates to higher versions, I guess I gotta do that. So let's do that. Let's go down to 2.4, 2.3. I have no idea what those are. Okay. Now, does this thing still compile? Can I still cargo build SBF? Oh, holy no, I cannot. What is all that stuff now? Mismatch type. Yeah, probably because once I started using older versions, They all need to be compatible, so I need to find one that is like compatible with all of them. See, that's why I wanted to have just a different God damn. Yeah, no, this is not, no, we're not gonna do that. Forget that. Forget that. Let's pretend we didn't use Mollusk. Then it still worked. Okay. It just doesn't feel right to me to have that in the same project, because I don't want to add unnecessary dependencies to my program, and I will need to mess with dependencies because I need to downgrade. So we are gonna go back to this. We are gonna use it like that, but we're gonna pretend we built it into our target. So basically what I'm gonna do is I'm gonna move my target deploy stuff into my Mollusk testing target. So basically I'm gonna copy target deploy to Mollusk testing target deploy. Oh yeah, recursively, of course. There you go. Now this target should have a deploy with my program. And then maybe if I run this thing here, nope, it still doesn't find it. But it also doesn't tell me where it's looking for it. Like, where are you looking for the SO file? My program SO. Where are you looking for that? Can you tell me that? Here are test programs, great, but then harness files, error CLI, bencher. Any like concrete examples? It's always a bit annoying. I'm pretty sure it's a cool tool and the people who use it know how to use it and can use it productively. But then if somebody is outside of that sphere and can't just ask one of the guys who developed this, I mean, I could. I probably know a few people who developed this. Yes, I do. But still, you don't want to be asked if you developed this. Ideally, I would figure this out myself, but it is difficult to figure this out myself. I don't even get a proper stack trace of this Mollusk thingy. Is there docs on this new? Create a new Mollusk instance containing the provided program. Attempt to load the program's ELF file from the default search paths. Default search path, here it is. I just need to be able to read. The following locations checked for: /tests/fixtures. The directory specified by the BPF out directory environment, the directory specified SPF out directory, the current working directory. Tests, fixtures. Okay, dear tests, fixtures. And into here shall move my program SO. Yes. Does that fix it? Yes. Now that we have my program in the correct folder, we can actually run this. And we get debug output. Oh look, we get the logs. That's program logs, just a bit ugly formatted because I have such a big screen. But basically, program being called, that many compute units being consumed, but it fails because missing required signature for instruction. Program result is failure. And then we also get the raw result, error, missing required signatures. And the resulting accounts, this is the pub key unique, the first one, 0 Lamperts, 0 data, system program owned. So yeah, I mean, cool. It's a bit ugly, the result, but it does work and it works fast because obviously it doesn't spin up anything. It just calls that program. It just does the minimum that it needs to be able to call the process instruction. Well, basically, whatever I call it, the entry point to call the entry point of my program. And it fails because I said it's read-only and not a signer. If I say, hey, make it true, make it be a signer, then it runs with result okay. There we go. Raw result okay, program result success. So if I was writing an actual test, I would now be like assert result, program result is program result. Mollusk program result success. Program result re-imported here. Okay, I can't have two program results, so I shall be more specific in Mollusk SVM Mollusk. Oh no, result. There you go. Then that assert should go through, but it's also not a test. If I would do a test, while we have the tests here, instead of having all of that in the main, put it in this simple test and make this a test simple instruction. Test. The program result is unused anyway. Well, then don't import that and instead import that from here. And then I can cargo test and hopefully it will give me an okay. If I had false here or for some other reason the program would not return what I would expect, then my test would fail. And that's how you write a simple test with Mollusk. So far so simple, right? This was all very easy. Yeah, it was. Of course it was. Easy. Let's also do some more complex stuff, because for now we literally called an instruction. Maybe you want to also do some checking on the result. We just check the instruction result, like the whether or not it executes successfully. But we can do more checks. Ooh, we can check for exact lamperts. Let's see. Let's add more checks. Let's do one with checks. So let checks be a vector of checks. Mollusk, VM result, check. What do we have here? Well, I would like to see this. Why does that not, why do you not? Here we go. What? Rust analyzer is a bit annoying again. So let's just do the same thing. We check for success, and instead of this process instruction, we will do process instruction, process and validate instruction. So then we get the instruction, the accounts, and we need to put in the checks like this. And then we don't need to assert this, because this will now already be inserted in here, I guess. Let's try. I would expect both of my tests to fail now. Yeah, 2 failed. In fact, let's just do the 1 test. So this fails now because I'm not a signer and I'm testing with expected success, but I got the failure missing required signers. So if it would give me success, then this test would pass. There we go. So that works. This check success. What else do we have? Check. This is not helpful, is it? Maybe it's because we're in a vector. Check. Here we go. Sometimes Rust Analyzer is a bit weird. We can check all rent exempt. We can check the compute units. We can check for error. We can check for some return data. We can check for accounts. If I wanted to check that it actually gets me that error, I can do a check for error and then program missing required signatures and put that instead of success. Also that should then pass. There we go. Nice. So now we're doing a check for the negative case. We check that there is an error. And with those checks, it's just easier than if we do the assert statements manually. It just makes it easier to write assert statements. Because obviously we have other things like the accounts. We could check that it's still owned by the system program or whatever. We could check account, the following pub key, my key 1 for instance, that we can check on data, lampert's owner, space, a slice of the data. But as I said, we could check that the owner is still the system program. No? Oh, I need to build this. I need to say .build. That will then give me an actual check. Otherwise, it's an account check builder. That's just, you gotta just know that. There you go. Temporary value, fine. System program be this. Then that should still work. But if I were to check that my program ID would own it now or whatever, then obviously the checks should fail because we got the system program and we expected this. Obviously, you do it the other way around. You expect something and the test fails if the program this here, if this does something weird to the account that you were not expecting, then the test would fail. Yeah, that's cool. And that runs pretty smoothly. I like it. You can build the checks quite easily. You can check on account state, even though there is no bank, there is no like many accounts. And if you do bigger, like more integration testing and other things that require more accounts, maybe you do want to use surf pool. But for such simple things, for like simple program unit tests, basically, that's pretty nice. You can also chain instructions, like do several, like the system instruction transfer. We can also do a chain and validate the checks. Oh, and in every instant we can do the check. So after every instruction we can do checks on account state. Cool. Or we can have stateful testing with Mollusk context. So we have a context in memory account state, and then we process instruction. And that way state is persisted within accounts between two of those process instructions by using this in memory account state. But for that, my program would need to actually do some stuff. Then we can do benchmarking. I feel like I should still do that and then we call it. So we need some way of working with state. So either I write some data or actually let's write some data, because the example with the lamperts is pretty trivial, but then actually reading data could be interesting. because again, we also don't have runtime. Let's try some stuff. This program will expect that account to sign and will try to write to it at the same time. Yes, we do that. Why not? And what do we write? We will do a bit flip or something. So first account, try borrow mutable data, and then data first byte, we toggle 1 bit. That's it. Cargo build, SPF. Then we copy it over there. We need to copy the target deploy my program SO to the Mollusk testing tests fixtures. And then we can do a check data test where we let that account sign and we expect success. We can also expect it to be owned by the system program. Check account data. Here I put the data that I expect it to have. Here I would expect it to have 1 byte of 1 and build this. That's gonna be interesting. No, slice. There you go. Because we never said that this account has any data. It's just a new pub key and the program will try to write to it. Let's see, because the runtime will usually say, hey, that's not gonna work because it's owned by the system program. But I mean, let's just test what happens here. I'm curious myself, I have no idea. It fails, it expects success and it gets program failed to complete. Probably because it panics because it can't write to an account that it doesn't own. So somehow I need to tell this key who its owner is. But that's just a pub key. How would I do that? Because I mean, what we're doing right now, we can check here. Basically, we're doing this, and if we simulate this, wait, I need to deploy the program first. If we were to run this here, through DevNet, then we get panicked. And that's the program failed to complete error then. We panic at 23.5. We panic at 23.5 where we write to the program, to the data, I guess. Because that account doesn't have data. It probably accesses, 1, 2, 3, 4, 5. Yeah, we can't access the 0 byte because it doesn't have data. So what you would need to do before is have an instruction. Well, yeah, you know what I would need to do. I would need to create that account and assign the bytes. How can I do that with Mollusk? It does have system instructions. So maybe I need to use them. System instruction. Oh, that's actually not even from Mollusk. That's just a Solana SDK. And I create account. The naming here is also weird. From pubkey is the payer. So now I need some other. But how can I tell you that one of the accounts actually has like Lamperts? Did you do that too? Starting Lamperts. There you go. Where do you use that? Is that just the default or did he set that up somehow? System account with Lamperts. Yeah, I think he used the system account with Lamperts. At the accounts, pubkey and accounts. Aha, here he says account default, but I can say, I'm gonna rename this now. I'll rename this the data account and then I'm gonna do a payer account and the payer account will be a system account with Lamperts. Where does it come from? Nobody knows. Oh, I can here just say new data with space. Hey, that's what I want. I don't need the payer account and I don't need the other instruction. I'm just gonna say new data with space, Lamperts, 500k, who knows? It doesn't matter. State, what is that? State T serialized. Well, how about this? Space 1, owner, my program. Would that do as an account here? I hope so. And then if we have that, hopefully now this check would also fail. Let's try. We're still failing with accounts. Expect reference got a vector. So you want a slice, you got a vector. No, still not. No, it's a slice of a slice. And you expected. That's the issue now. You have pubkey to Solana account, but you found result to, okay, wait, hold on. When I did this here, this thing gives me a result instead of the actual account because the new data gives me a result for the self. Okay, I'm just gonna unwrap this here. There you go. Then it should be an account again and then it should be fine. Yeah, I think that looks better now. Cool, but it fails. That's what I expect. Shit, unwrap. Unwrap fails, size limit. Okay, so this doesn't work because size limit, because also I don't know what that does really. T is an I32 1. And what exactly are you complaining about? Oh, because we have an I32 and the size is 1 byte. Is that the problem? Is that my problem? Now we have a U8 one. How about now? Yeah, nice. Wonderful. We expected success and we get read-only data modified. Well, that makes sense because that account is now read-only and we modified the data for it. Nice. Not sure where that check really happens, but Mollusk still somehow adds that, because usually that's something that the runtime does, not the program itself. The program itself just modifies it, although if it's not writable, yeah, whatever, somewhere that check is done. But if I say, hey, make it writable, then it should fail somewhere else, namely here. Yes, because now we're expecting the system program to own this, but actually my program owns it. Perfect. That's actually what we would expect. The test is just not correct. And then also we would expect that the data account data is actually that byte toggle, because that's what the program does. Will the check go through? The check goes through. Wow, we actually test that my program toggles this first byte, the first bit of the first byte. Nice, nice. I like it. We can test on the data. And now we can come to the part with the actual context, because if I did the exact same thing again, and I say again, check that same thing with the same checks, I think it will still come back with okay, because every time I do this, it starts from new, basically. It doesn't remember state. So if we were to do it correctly, and at the check 2, the second checks, we would assert that it's 0 again, then obviously that would fail, right? Yeah, because we expect the data to be 0, but it's 1, because every time I execute, it starts from scratch. So we gotta work with this stateful Mollusk context. How do we do that? By getting the context with context in memory account store, and then saying context process instruction. So we're not working on this Mollusk thing here, but on the context. But where's the in-memory account store? Oh, where does that live? Here they build it like this and implement account store for the in-memory account store. Am I supposed to do this as well? I mean, I don't see how I would otherwise be able to use an in-memory account store. So basically we just create a hash map. Isn't that somewhere implemented already? Maybe it is, but I don't find it. But anyway, so we can get account or we can store account. Yeah, fair enough. I'll just use that. And then I have this in-memory account store, and then I have this context. So now instead of Mollusk, this instance, I will now use that context for processing and validating my instructions, which I hope works the same way. Nope, it just expects 2 arguments and found 3. So apparently the checks I do then afterwards. So first I just process, wait, no, it's just, we don't need the accounts, other way around. We don't need the accounts, but we do need the checks. That way, okay. Because the accounts are now in this context. But I still need to somehow get those accounts in the context then. Oh yeah, indeed. Here he actually, simple in-memory account storage. That's literally, he also has that. It's literally that implementation as well. And you can have whatever implementation for storing your accounts. That looks fine, but it's not gonna work because I don't have the correct account state in the beginning. Failed because program failed to complete. Yeah, because the account is all still default and I somehow need to get that account in there, in memory account. So I guess I'm gonna have an account store, that is this, and then account store account. Here I will do the data account and this thing. That's what I will need to do. Cannot mutate, okay. And then Mollusk with context, this account store. You think that will work? That would be cool. Yeah, and it passes, but I still don't trust it fully. I mean, we have 2 times the program being called, so that's cool. But just to make sure that this test is actually executed as well, if I would test here for data has 2, does it then fail? Yes, then it fails. Okay. So only if it toggles back to 0, first execution we test that it becomes 1 and then it toggles back to 0. Because what my program does is an XOR, we toggle the lowest bit of the first byte, and so it will switch between 1 and 0 with every execution. Nice! And that's how we also do that with persistent accounts. Good! I think that's good enough. I think I gave Mollusk a good spin. We tried it out. There is more features. I mean, you can even do custom sysvars, but that might be a topic for a future video, like so many other things. I'm gonna leave you here for today. Thank you for watching. Try out Mollusk yourself if you feel like that's the right thing. There's also Surfpool, which is also really cool, but it depends what you need, right? If you just wanna have a quick harness for testing some stuff, and you just have a few accounts and you wanna manually be able to tweak them and stuff, it's more flexible. Surfpool is more real. It behaves more like an actual cluster would behave because it gets all of the accounts and it works with the programs together. But for just testing one program and smaller tests, unit tests, being able to manually adjust what data is where can actually be super nice. And for that, Mollusk is a nice tool. It's somewhat simple to work with it. It's not super well documented, but it's easy enough for me to get started with it without any issues. So that's nice. It also works out of the box, except for a few dependency issues because it's not using the very newest Solana SDK. But overall, it's actually super nice to work with. I think certainly less of a hassle than testing with the Solana test validator. So I give you that. And otherwise, it's your choice whether or not you want to work with it. I do, however, highly recommend that you do some testing. Also, maybe I should still say that this is not the same as, sending transactions. It's still just a testing harness that lets you test the little bits. But on a transaction level, the program might still behave differently because you have compute budget limits, you have account size limits, all of that stuff. I don't know how much of it is implemented in Mollusk. Probably not all of it. Just be aware of that, and also then do proper integration testing with a proper validator setup, like with the real Solana runtime. But for quick tests, small tests, lots of them, this SVM, the Mollusk SVM, actually works pretty well. Now I think I said everything. All right. Give this video a like, watch those other videos if you feel like doing that. And if you feel like it, you can also subscribe. You don't have to, but you watched all that way to the end of the video. So I'm assuming that you like more of my content, and subscribing helps you find my videos. Yup, so I will see you in the next one, because there will be next ones, because I have so many things to talk about. As I just figured out again, things keep changing. I need to keep making videos. See you in the next one. Good enough. Yo, I'm out. Done. Let's run. But yeah, it was good. It was actually, it's a nice tool. I mean, I enjoyed that. Good that I made a video about it. It's nice for testing. You can productively use that. I like it. Yeah.